Today's video will explain two implementation options for the linked list. Hello, I'm James Helfrich. One of the most commonly used data structures is a linked list. The linked list allows us to add and remove elements from the middle of the linked list in constant or O sub 1 time. This video will explain two different implementation options for the linked list. There are two implementation options for the linked list, a singly and a doubly linked list. Now, a singly linked list, every node points to the next node in the sequence and is only possible to move forward. So we can represent this with a node, which is a square, and then an arrow to the next node, to the next node, to the next node. Notice the last node has an end cap, which means it's a null pointer, which means there's no node following 8. Now, a doubly linked list, every node points to both the next one and the previous one in the sequence, and therefore it's possible to move both forward and backwards. And we represent this with an arrow pointing forward and backward from each node. Notice node number 2 has a next node but not a previous node, indicating it's the head. And notice node number 8 has no next node but a previous node, indicating it's the tail. Okay, let's start with a singly linked list. Now there's only one pointer per node, so the class diagram will only have a single pointer. So we'll start by calling our class node. And then we're going to have a single member variable called data, which is going to hold, in this case, 2, 3, 4, 6. But this is of type T. It doesn't have to hold just integers. It can hold anything. And because that's a T, it's a template class. Next, we have a single pointer called pNext, and it's going to be of type node, but it's going to point to itself. And this is going to be a pointer, so it's going to be a aggregation, not composition. And how many do I have? Well, 0 or 1. 0 if there's no next pointer, which means I am the tail, or 1 if I'm not the tail node. Okay, let's implement this, and I will use C++ here. Now, the first thing I'm going to do is I'm going to create a structure type of type node. Okay, now that I've done that, I got to create the data item, and this can be of type T. Now, notice that the data type is T, but I haven't defined it yet, so I need to make it a template class. Okay, now I have to create a pointer to the next node in the linked list. Now that my definition of the node class is finished, I will instantiate one instance, and I'll give this the value 13. Okay, now that I've done with that, I'll create another node, and I'm going to give this value 15. Okay, now that I'm finished, what happens when I run it? Let's take a look. Okay, phead is going to point to some value. When I expand it, my data is 13, which is what I expect, and my pNext is another value. When I expand it, its value is 15, and pNext after that is the null pointer, which means I'm at the end of my list. Now let's implement a doubly linked list. Notice there are 2 pointers per node. So we're going to have a pointer to the previous and pointer to the next, right? So once again, we're going to call our class node, and we're going to have a member variable called data, which is going to be a template. And just like before, it's going to have that template indicator. Now have a pointer to next and a pointer to previous. And so this is going to be through aggregation. Now there's going to be 0 through 2 instances of this. 0 if I am both the head and tail. In other words, there's no previous or next. 1 if I'm either the head or the tail node. And 2 if I'm somewhere in between. All right, in order to implement the doubly linked list in C++, I'm going to create a node structure just like before. Just like before, I'll have one data member variable, which is a template variable. Now I'm going to have 2 additional member variables, pointer to previous and pointer to next. Okay. Now, remember, every time I instantiated a member variable before with my singly linked list, I had to initialize my member variables. In order to prevent that, I'm actually going to create constructors, which will simplify this. All right, now that I finished, I can instantiate a single node, and I'm going to give this the floating point value 11.11. All right, now that I've done this, I will create another node, and I'm going to put this on the back of this one, and I'm going to give this the value 22.22. And just for fun, I'm going to create another one that's going to go in the middle, and I'm going to get this value of 99. Okay, these three nodes are not connected, so now I'm going to have to hook them up. Okay, now that they're all hooked up, let's see how it goes. I will run the code. Okay, so we'll start with p head. P head has the value 11.11, of course, with the usual floating point rounding. P next is the one after it, which will have 99. And after that will be P tail, which has 22.22. Now, P tail, P previous will give me back to the middle one, and the middle one, P previous, will give me back to the head. And then, of course, P head, P previous is the null pointer. So I can go forward and backwards with a doubly linked list, where the singly linked list, I can only go forward. You can learn more about this in the implementation section of the linked list chapter of the C++ data structures textbook.